Hello everyone, I am Dattatreya Nikam. Welcome you all on our channel eFunda for new day, new topic. And our today's topic is very interesting, that interview question. And if you are new to our channel, then please note that this will be presented in a parts so as to have a better understanding as well as guidance on the interview related question. And if you are new to our channel, then please visit to our channel eFunda and watch all the videos created various topics of engineering, and same can be seen in our playlist. Also, for our viewers, we have also started our new blog, that is a eFunda channel, where one can see the detailed technical discussions as well as article on various technical topic. And don't forget to subscribe to our channel and also press the bell icon to get latest notification on upload of our new video on our channel eFunda. So let's begin with our today's topic, that is interview questions. Basic instrumentation and control interview question. In this series we are going to see the control valve. Question first, what is the control valve? A control valve is a power operated used to regulate or manipulate the flow of fluids such as gas, oil, water and steam. One can refer to the picture where one can see the control valve as well as the actuator is shown, and similarly in another animation one can see how the control valve is being operated and control or regulate the flow. It is a critical part of a control loop and is an example of a final control element. The control valve is by far the most common final control element used in industry today. Second question, what are the different types of control valves? The different types of a control valve includes globe valves, butterfly valves, ball valve, diaphragm valves and plug valves. Similarly, the third question, components of the control valve. One can refer to the picture where one can see the various parts. Similarly, valve body, bonnet, trim, plug, cage, seat ring are different types of the component used in the control valve, and those one can correlate with a given picture. Fourth question, what is the function of an actuator in a control valve? The actuator is the component of a control valve that converts the control signal, example pneumatic, hydraulic and electric, into mechanical motion to open or close the valve. Fifth question, what is the function of a valve positioner? The valve positioner is used to increase the accuracy of the valve action. Positioners are used in control loop to completely perform the function of the final control variable. They position the valve by increasing or decreasing the air load pressure onto the actuator. Sixth, how is the CV, that is the flow coefficient of a control valve, is calculated? The CV is calculated using the formula CV is equals to Q by under square root of the delta P, where Q is the flow rate in gallons per minute, that is a GPM, and delta P is the pressure drop across the valve in PSI. Seventh question, what is the rangeability of a control valve? The rangeability of a control valve is the ratio of the maximum to minimum controllable flow rate. It is an indication of the valve's ability to accurately control flow over a wide range of the conditions given for those valves. Eighth question, what is the common trim material used in the control valve? The common trim material used in the control valve, which include stainless steel, carbon steel, brass and bronze, depending on the application and the process condition for which the application is being made through control valve. Ninth question, what is the cavitation in control valves? Cavitation is the formation and subsequent collapse of a vapor bubble in the control valve due to pressure fluctuations, which can cause damage to the valve and it affects its performance. Question 10, how can cavitation be prevented in control valves? Cavitation can be prevented in a control valve by using anti-cavitation trims, installing pressure reducing orifice plate, increasing the downstream pressure or using a valve with a higher pressure rating. 11th question, what is the flashing in the control valve? Flashing is the process of a liquid rapidly changing into vapor due to drop into the pressure, which can cause damage to the valve and affects its performance. This is similar to the cavitation. 12th question, how can flashing be prevented in control valves? Flashing can be prevented in control valve by installing a downstream pressure control device, reducing the pressure drop across the valve, or using a valve with a higher pressure rating. 13th question, what is the purpose of a control valve position feedback signal? The control valve position feedback signal provides information about the actual position of the valve, which can be used to verify the valve's performance and control its accuracy. Question 14, what are the different types of valve actuators? The different types of valve actuator includes pneumatic actuator, hydraulic actuators, electric actuator, and a manual actuator. Question 15, understanding of rangeability and turn down in control valve. Valve rangeability. Rangeability indicates the extent of a flow value that the valve can reliably regulate and is often reported as a ratio of the largest to the smallest flow that can be controlled acceptably. One can refer to the picture where one can see how the control valve opening is there and the discharge is open. The rangeability refers to a control valve's inherent characteristics, which is defined as the ratio of maximum flow to the minimum controllable flow. Now another important term is the turn down. It is the ratio between the maximum usable flow and the minimum controllable flow, usually less than the rangeability. Turn down ratio refers to a valve's installed characteristic. One can refer to the table where one can see the flow meter rangeability, where the ratio with reference to different level is shown, that is the 5%, 10%, 12.5%, 25%, and their turn down values are also indicated. Generally, the term rangeability is used to describe the capability of a control valve, that is a ratio of a maximum CV of the valve to the minimum CV at which it can control, whereas the turn down is generally used to describe the requirement of an application where this control valve is being used. Now most critical part we are seeing as a case study example on cavitation and flashing. One can refer to the picture where one can see the valve arrangement and inside construction, and similarly one can see the two graphs where first graph shows that the valve inlet where pressure is the P2 and at the valve outlet that the pressure P2 will be there. Once the valve is into operating condition, then P1 is started flowing and it is passing to the valve before PV. There no cavitation is occurring. Simultaneously into the second graph where one can see the pressure P1 is crossing the vapor pressure value, where at the vena contracta point pressure where the bubbles are created, and that is called incipient cavitation, where the bubble formation is done and the recovery is there. There one can see the difference between P1 and P2, that is called as the pressure drop, and this is how the cavitation condition is occurred into the valve, and somehow it is getting recovered to the discharge by crossing again the value of the vapor pressure. Similarly, on the second graph one can see the total valve inlet and valve exit condition when P1 is started flowing through the valve at the restriction point where the pressure contour as a flow passes through the valve, then it crosses to the PV value where the vapor bubble form below the fluid vapor pressure, and then the low pressure and high pressure velocity at the vena contracta point, and then the vapor bubble collapse above the fluid when it's crossing to vapor pressure. This is how the recovery is happen and liquid passes through the valve. Similarly, in the another figure one can see where the P1 is crossing the PV value where the bubble formation is started and the later bubbles at the Vienna contract top point remain same, and it is continued to be remain below the vapor pressure, where bubble continue into the downstream where the pressure recovery is not there, and this condition is called as the flashing. For better understanding, refer animation from Vector Solution Industrial, where one can see how the internal valve is operating and how the conditions of the cavitation and flashings are being occurred inside the valve, and what are the takes of these cavitation cases.
After flashing, the pressure begins to recover. If the pressure increases high enough, some or all of the bubbles implode. The implosion of vapor bubbles is known as cavitation. It is often possible to hear cavitation in a system. The early stages of cavitation create a cracking or popping noise, or may sound like rocks flowing down the pipe. Later stages may create a steady sizzling or hissing sound.
Now we have reached to the stage where one should understand the types of control valve. One can refer to the classification flowchart, where control valve is divided into the linear sliding stem valve or a rotary type valve. Further, this linear type is divided into the diaphragm, globe, pinch type valve. Rotary is divided into the butterfly, ball, and eccentric plug type rotary globe valve. One has to understand the features of the linear valve, as they have low recovery and can throttle for the small flow rates. It offers a variety of special trim designs. Additionally, they are suited for the high pressure applications, and usually flants or threaded type connections are provided for such arrangement, and separable bonnets are available in these types of valve. Further, for these rotary types, actually it's a streamlined flow path. That means these are connected in line as a flow path valve. High recovery valves are considered as a rotary valve. Here more capacity and less packing, where they can handle slurry as well as abrasive services, high rangeability and flangeless valve, and have an integral bonnet. Now we will see major type in a brief. Now diaphragm type, one can refer to the animation where diaphragm valve operation is shown, which is simplest, tight shut off, isolated, ideal for the corrosive, slurry and sanitary services, where see how the flow is being cut off if the valve is closed. Similarly, the second type is a globe type valve. Globe valve is also called stop valve, shut off valve. The opening and closing parts of the globe valve is can seen from the animation, where plug shape is a valve disc, the sealing surface is a flat or conical type, and the valve disc moves linearly along with the center line of the fluid. In the animation, one can see the operation of the globe valve. As this animation we have used working based on the hand wheel, but our purpose of having the control valve which requires automatic operation with the help of actuators. Similarly, third type is the pinch type valve. One can refer to the animation how the flow is passing through the line and the valve is getting pinched. At the close of the valve occurs a pinching of the elastic sleeves, thereby damming the flow or stopping the flow. Opening and closing of the valve is realized by different types of the actuator, that is a manual, pneumatic or electric type. Now to rotary type, here mainly is a butterfly valve. One can refer to the animation how the butterfly valve is shown and connected, where butterfly, which consists of a rotating disc in trunnion bearings. Traditionally, these butterfly valves were limited to the low pressure and temperature due to their inherent limitations of the soft seated which are being used in the butterfly valve design. Second rotary type valve is the ball valve. One can refer to the below animation where the ball valve is connected in a line. That means this valve is called as inline valve, where the actual tight shutoff high capacity with just a quarter turn to operate. One can see how the flow is flowing through the valve when the valve is open and how the tight shutoff is being achieved. A ball valve is consists of a spherical ball located between the two sealing rings in the simple body form. The valve has a hole allowing fluid passing through the line when the valve is open. This gives either full bore or nearly full bore flow with a very little pressure drop. And the third type is the eccentric plug rotary globe type, which shows a typical eccentric plug. These valves are normally installed with the help of plug spindle horizontal as shown and attach actuator situated along the valve. This is how the control valve types are categorically divided. So we have touched each type of a valve, and for further classification of each type, one can study this classification table so as to understand the types of a valve, types of a single seated, double seated or three-way type mixing in a linear sliding stem type. Further, rotary valves are also classified, which are listed and shown for ready reference. With this, we are concluding on our today's topic, and you can find our channel details as follows. If you are new to our channel, that is our YouTube channel eFunda, then subscribe to our channel eFunda and don't forget to press bell icon to get latest notification of upload of our new video on our channel eFunda. Similarly, you can follow us on a Instagram page. Similarly, you can follow us on our Facebook page as well. And keep watching our channel eFunda for various topics related to engineering and a project. With this, we can assure you this will help you to better your understanding on engineering and a project topic. Keep watching our channel eFunda. Thanks. Watch our channel for new day, new topic.